Hello everyone, it's Red Saber here from Saber C++ with another Arduino tutorial. And today we're going to be learning how to create this endless coin collector game where you collect the gold coin and avoid the bombs. If you don't know what the 8BitCade is or how to assemble it, check out the links in the description for a full playlist on how to assemble and program games for the 8BitCade XL. Remember, you can upload programs to the 8BitCade XL just like any other Arduino through the Arduino IDE using this port here on top. Let's get started. First, I'm going to create a new file by going up to this menu here with the three dots and selecting New tab. I'll name the new file sprites.h because this is where we'll store the images that are used in our game. Now, let's create some of these sprites. I'm going to use a website called piscalap.com, so you can type that into the search bar or go using the link in the description. The first thing to do is click Create Sprite and then click this Resize button here and resize the area to 8 pixels by 8 pixels. Then I'm going to change the color of the pen to white. So the primary color is white and the secondary color is transparent. We're going to need 4 sprites for our game: the background, a player, a coin, and a bomb. For the background, I'll just throw on a few dots, sort of like cobblestone or something. And that's it. Then I'll create a new frame for the coin. For the coin, I'll start by creating as much of a circle as you can get on 8 by 8 pixels. And in the middle, I'll put G, because it's supposed to be a gold coin. It doesn't look very good up close, but it'll look much better smaller. And then we need a bomb. So I'll once again create a small-ish circle type thing. And I'll just add a fuse sticking off of it. There we go. Now we can download each of these by going to the export button here and downloading the single frame as PNG file option. Once we have all 3 of those, we can go to the image converter, which you can also find in the description, and then we'll need to drag and drop our image files into this box here. So I'll drag the first one into there, and as you can see, it'll give us this little texture. Now this is our background, so I'm going to replace everything after this word progmem and before these square brackets with the word background. Then I'll copy all of this here and put it in our Arduino IDE. I'll do the same thing for the other 2 images. Dragging their file over, renaming them. This is the coin. And then copying them into the Arduino IDE. And there we go. Now we have our background, our coin, and our bomb, all here in a way that the Arduino can understand them and display them to the screen. Now, for our player, we want him to look like he's walking. So we'll actually need to have multiple frames. So I'll click Create Sprite to go ahead and create a new one. And once again, we'll have to resize the area to 8 by 8. And then I'll start by drawing our character. Oops, we want that to be white. I'll just draw, a little hat and then a sort of head and then a body. And we also want to make sure he has 2 little legs so that we can change these on the second frame, which we'll create by clicking the duplicate button. And we'll erase the frames from the outside and put them inside. Now this looks a little weird, but if we look over here in this window up here, we can see it kind of looks like he's walking because his legs are moving back and forth. And that's what we want. So now, instead of exporting a single frame, we'll need to click the sprite sheet file export option and download that. And yeah, you can see here in the file browser that it has both versions of him stacked on top of each other. So if we drag it here, we can see it's created a longer array than we've seen in the past. And after we rename this player, what we want to do is change it from saying 16 here to saying 8. Because what it did was it said, oh, you have an 8 by 16 image. But actually we have 2 8 by 8 images. So if we make this 8 and 8, then it'll know, oh, I should make this 2 8 by 8 images. And then the Arduino will be able to switch between them to make it look like he's walking. Alright, so let's go ahead and draw some of this to our screen. At the top, the first thing we'll need to include is the sprites.h file that we just created. Now, this will be in quotes because when you're including something in the same directory as the main file, you'll use quotes. However, when you're including something from the libraries, like for example the arduboy2.h, which we want to include, you'll use chevrons. Then we can create an arduboy2 object called arduboy, and then we can start our program. In the setup function, we can run the arduboy.begin function to go ahead and initialize it. We can run the arduboy.setFramerate function to set the frame rate to 60 frames per second. And we can run the arduboy.clear function to clear anything that was on the screen before we started the program. In the loop function, we'll need to start by saying if not, the exclamation point is for not, arduboy.nextFrame return. So if the arduboy isn't ready for a next frame, because it only allows frames 60 times per second, then it'll go ahead and return, and we won't do any of our game logic because we only want it to be updating 60 times per second. So then we'll want to run the arduboy.clear function because there will have been something on the screen in the last frame, and we don't want to draw over that. We want to draw on a fresh, clean slate. And then we'll run a function called showBackground, which of course doesn't exist, so we'll need to create a void showBackground below the loop function here. And it doesn't have any parameters, so what we'll be doing is we're going to loop through the screen in both dimensions, x and y, and we'll simply be putting our background image over and over again to cover the whole screen. So we'll say for int background x equals 0, background x is less than 128 because that's how large our screen is, and background x will increase by 8 pixels because our image is 8 pixels wide. If you made a 16 by 16 image, that would be fine. You could then say background x plus equals 16. Then we'll say for int background y and do the same thing with it starting as 0. It'll only increase till 64 because the screen is only 64 pixels tall, but it'll still increase by 8 each time because the image is 8 by 8. And inside of these loops, what we want to do is we want to call sprites : draw over right. And this will just draw an image at the position we put in, which will be background x and background y. And we'll draw the background sprite and frame 0. Now, since it only has one frame, we have to do frame 0. But for a sprite with multiple frames, we could select one of the frames. And this will just draw our background sprite over anything that's already there. In this case, there won't be anything there, but if there was something, it would go ahead and draw this on top of it. Let's try it out. And now our background image is tiled across the whole screen. It's a bit boring, but once we add the player and everything else, I think it'll look pretty good. At the top, let's create a few variables for the player. The first one will be an integer called moveDelay, which we'll set to 30, and this will change how fast the player moves. Then we'll create one called frameDelay, set to 100, and this will change how fast we go through the frames in the player's animation. And the last one, called playerFrames, which will hold how many frames the player's animation actually has. In this case, 2. We'll also need an int called playerX, which I'll go ahead and set to 5, and an int called playerY to hold the player's Y position, which I'll set to 15. This will put the player pretty close to the top left corner. Then we'll need a long variable, which is basically an int, but it allocates a lot more storage size so we can hold very large numbers. And this will be called last frame change time, and we don't need to initialize it to anything. We'll also need to create long variables for the left button press time, the right button press time, the up button press time, and the down button press time. After the arduboy.clear function statement in the loop function, what we'll want to do is create a long called current time and set it to millis, which is getting the milliseconds since the program started. So we can compare the current time to a previous time held in one of these variables up here and determine how much time has passed since that time. Then I'll create a bool called moving, which I'll set equal to a new function, calculate movement. And then we'll want to create that down below. So I'll create this right below the loop function, and it will need to be a bool because we're setting a bool variable equal to it. And we'll want to pass in a long variable called current time. So back in the loop function, we'll actually pass in the current time variable. And in calculate movement, we'll start by creating a bool called moving, and we'll set it to false. At the bottom, we're going to return this moving bool. And in between, we'll actually do our logic to calculate the player's movement and move them around. So we'll need to check if arduboy.pressed left button, so if the left button is down, and if the current time minus the left button press time is greater than the move delay. So basically what we're checking here is if the left button's down and if it's been the move delay, which is 30 milliseconds. So if it's been 30 milliseconds since the left button press time. So if this is the case, then we'll set the left button press time to be equal to the current time. So basically, while the left button is down, this will keep triggering every 30 milliseconds. And inside of this, what we'll do is we'll set the player X to be decreased by 1. And we'll set moving equal to true, because the player just moved. So basically, what this means is that the player will be able to move to the left, which is decreasing the X value, by holding the left button down, and they'll move 1 unit, or 1 pixel, every 30 milliseconds. Then we want to check otherwise if the right button is pressed, and we'll do the exact same thing, but with the right button and the right button press time, and we'll be increasing the player X by 1. Then we'll copy both of these and do the same exact thing for the up and down buttons. Remember that the up button should be decreasing the player Y because 0 on the y-axis is at the top of the screen and 64 on the y-axis is at the bottom of the screen. And as you can see, we're also setting the moving variable each time, so if the player is moving in any axis or any direction, then we'll return the moving variable as true. So back in the loop function, now that we know whether the player is being moved and we're moving the player, we can create another function called update frames. And we'll pass into it the moving bool and the current time. So I'll collapse the calculate movement function and create this below that. So this will be a void, and we're passing in the bool moving and the long current time. So we want to check if the moving is equal to true, so if the player is moving, and if the current time minus the last frame change time, which we declared up the top here, is greater than the frame delay. So here we're basically doing the same thing we did for the player's movement, but with the player's frames. So the frame will only be allowed to change while the player is moving in some direction, and every 100 milliseconds, so 10 times per second. And if this is the case, of course, we'll need to set the last frame change time to the current time, because we're changing the frame. And we'll need to create a variable to hold the player's frame. So I'm going to create an int called player frame, and I'll start this out as 0. So whenever we increase the player frame, we can increase it by 1, and then we'll also need to check if the player frame is greater than or equal to player frames, because we don't want this to get beyond the number of player frames. So if it is, then we'll set the player frame back down to 0. The last thing we need to do is create a function called showObjects. And this will show all of the objects we'll have in our game, but for now the only object we have is the player. So down below the showBackground function, create a void called showObjects. And inside of it, we're going to run that same sprites drawOverWrite function to draw the player on top of the background that we already created. So we'll be drawing him at player X and player Y. We'll be using the player sprite from the sprites file, and we'll be using the player frame, which we're updating in the update frames function. Alright, let's try it out. And of course, update frames actually needs to be called update frames in order for the compiler to recognize it. So let's go ahead and update that, and we should actually be able to upload our code. As you can see, we can now move the player around, and it plays the walking animation when we're moving, and it doesn't when we're not. Unfortunately, the player can go off of the screen, and there's of course nothing to do yet. So let's keep the player in bounds and add a coin for the player to collect next. Before we do, if this video has been helpful to you so far, please give it a like so I can keep creating more. So we'll need to create an int for the coin X and an int for the coin Y. Let's call a start game function from the setup function, which will then create after the setup function and before void loop, so that it's just right here. We'll add more in a moment, but inside of this, for now, all we'll do is run a placeCoin function, which I'll create down here at the bottom. This will be a void called placeCoin, and we don't need any variables. Now, inside of here, what we'll do is we'll randomly place the coin somewhere inside the map. So we need to call the randomSeed function to set the seed of our random number generator. Now, different seeds to the random number generator will cause the random number generator to produce different values when we ask it for a random value. So if we seed it with the very precise time, then we'll never be seeding it with the same value, so we'll always get different random values. So we'll want to set the coin X equal to random, and this will be from 0 to whatever value we put in, which will be 128, because that's the width of the screen, minus 8, because the coin is 8 pixels wide, and we don't want any of the coin to stick off of the screen. We'll do the same thing for the Y, setting it to a random value from 0 to 64 minus 8, because the screen is 64 pixels tall. Then, in the showObjects function, we'll want to draw the coin. Now, I'm going to draw it before the player, so that if the player is overlapping with the coin, the player will be drawn on top of the coin, so the real player can see the player sprite. So this will be sprites, draw over right, and we'll be drawing at coin X and coin Y. We'll be drawing the coin, and it only has one frame, so we'll set it to frame 0. Now, the next thing we'll need to be doing is calculating some different collisions to keep the player from going off screen and to check when it overlaps with the coin. So to do all of this, I'm going to create a helper function, which will be a bool, and I'll call it objects overlap. And what we'll do is we'll put in integers for two objects, call one object 1 and the other object 2, and each of them will have a minimum and maximum x and y values. So they'll be in object 1x, object 1 max x, object 1y, object 1 max y, int object 2x, int object 2 max x, int object 2y, and int object 2 max y. The calculation really isn't that complicated, so we can do this all on one line and simply return it. So we'll need to check if object 1 max x is greater than or equal to object 2x. So if the rightward side of object 1 is past the left side of object 2, and object 1x is less than or equal to object 2 max x. So if the left side of object 1x is before the right side of object 2x, so all of this means the objects are overlapping on the x-axis. And we'll check the same thing for the y. I'll just go ahead and copy this and paste it. Swap out all of the x's for y's. So if the objects are overlapping on the x and y, then we'll return true, and otherwise this will return false. Now that we have this, let's create a void called check collisions, and in here we'll check all of the collisions for all of the objects, which is currently only the player and the coin, and of course we'll keep the player from going out of bounds. So let's start by creating player max x, which we'll set to the player x plus 8, since that's the width of the player sprite, and player max y, which we'll set to the player y plus 8. Now that we have these, we can check if the player x is less than 0. So basically, if the player is going off the screen to the left, then we want to go ahead and increase the player x by 1. And we'll increase the player max x, because the player is always 8 pixels wide. Otherwise, if the player max x is greater than 128, which is the right side of the screen, then we'll actually want to decrease the player x and player max x. Then I'll copy this if and else if statement and paste it down below, once again setting the x's to y's, and of course we'll need to set the 128 to 64 because the screen is only 64 pixels tall. Now that we're keeping the player from going off screen, all we need to do is check if the player is overlapping with the coin, and if it is, place the coin again somewhere else. For this, we'll use the objects overlap function that we created up above. So we'll check if objects overlap, and object 1 will be the player, so we'll pass in the player x, the player max x, the player y, and the player max y. And object 2 will be the coin, so we'll pass in the coin x plus 8, which is the width of the coin y, and the coin y plus 8, which is the width of the coin, or the height of the coin. So if the player is overlapping with the coin, then let's just go ahead and place the coin somewhere else randomly. The last thing we need to do is go back up to the loop function and call the check collisions function right after the show background function. Now let's try it out. As you can see, we can now move the player around, but he won't go off of the screen, and if we collect the coin, it'll get moved to somewhere else. It's still not very interesting, so let's add some bombs for the player to avoid, and a score to track how many coins the player can collect. Before we do, if you'd like to see more content like this, please subscribe so I can bring you more videos. Thanks. For our final variables, let's start by adding a score integer, which will start out as 0, of course, a bool called game over, and then, since we're going to have several bombs, the most efficient way to store their positions is an array. So I'll create an int bombs, which will be an array that will be 5 long, let's have 5 bombs, and 2 wide, because each bomb will need to store the x and y values. So this will have 5 items, and each of them will start out by just holding 0, 0. So we'll have the 5 positions for the 5 bombs, which we'll set randomly, and then we'll be able to change these and display all based on this array. We'll also want to create an integer variable called bombs count, which will store the number of bombs that we actually have in the array. We can calculate this by checking the size of the entire bombs array and then dividing that by the size of a single array inside of that. So let's do bombs 0. In the start game function, let's go ahead and set game over to false and set the score to 0. And then we'll add another function called place bombs after the place coin function. We'll create this in just a moment. But let's also create a void game over, which will start by setting game over to true. Then we'll clear the Arduboy screen of any bombs, coins, or players, or whatever's on it at this point of the game. And then we'll display that the game is over, and we'll show the player their score. So we'll have a string called game over message. And for now, I'll just set this to game over with an exclamation point. To display this in the center of the screen, we can run the arduboy.setCursor function and then calculate where we should start this so that half of it is before the center of the screen and half of it is after. So the center of the screen on the x-axis is 128 divided by 2, and from that we want to subtract 6, because each character is 6 pixels wide, times game over message dot length. Then for the height, let's set it to 64 divided by 2 minus 8. So the bottom of the characters would be touching the middle line, but all of the characters would be over. Then we can actually run the arduboy.print function to show our message. Then we'll create a string called score message, and we'll set this to be a string with score and then a colon, space, and then we'll create a new string from our score variable and add that onto the end. So if the score is 5, then it would say score 5, so the player will know their score. Then once again we can run the arduboy.setCursor function and set it to 128 divided by 2 minus 6 times the score message.length. And we'll set the height to 64 divided by 2 plus 8. So this will be just a little bit below the central line. So we'll have a little bit of a gap between these two lines. Then we can print out our score message. Now that we have the game over function dealt with, let's go into the loop function and actually call this. In the loop function, we should check if the game is over before we do anything else. So if game over, then we'll want to check if the arduboy.pressed A button. So if the A button is pressed, then what we want to do is restart the game. So we can simply call the start game function to restart the game. Otherwise, we'll simply return so that we don't do any of the game logic and simply stay on the game over screen. After we check collisions, it's possible that the player has won or lost the game, and so the game is over. So before we display the objects, we want to check if the game is over, and if it is, we'll return. In the showObjects function, we'll need to show the bombs as well. So I'll create a for loop, which will start an int called bombIndex, which will go from 0 for as long as the bomb index is less than the bombs count variable we created up above, and will increase by 1. Then let's go ahead and get this bomb's position. So this bomb's x position will be the value from the bombs array at the correct bomb index, and it'll be the 0th value of that inner array. The bomb y will also be the value from the bombs array at the same index, but it'll be the second value in the array, which will be at index 1. Now that we have the correct position, we can run the sprites draw over right function, draw at bomb x, and bomb y. We'll draw the bomb, and it'll be at frame 0 since that's the only frame for the bomb. We also need to implement our place bombs function, which will be a void. And inside of it, let's copy all of this from the showing objects function to the place bombs function. And instead of setting an integer equal to the item from the bombs array, we'll actually set each item from the bombs array equal to a random value. So first we want to seed the random number generator, running the random seed function and setting it to current time in milliseconds. And we'll just divide that by the bomb index so that we can make sure that each of these loops, even though they're running very close to each other and might have the same millis value, don't end up with the same random positions. So we'll set the first value to a random value from 0 to 128 minus 8. And we'll set the y value to a random value from 0 to 64 minus 8. Once again, we're subtracting 8 so that none of the bomb's image goes off of the screen. We also want to make sure that we don't place a bomb very near the player, as this could be frustrating. So we want to check if objects overlap once again, and for this, we'll actually slightly modify the player x and max x values and the player x, y, and max y values so that we make sure that the bomb is at least 4 pixels away from the player. So we'll check if the player x minus 4 and the player x plus 8, so the player max x plus an additional 4, and the player y minus 4, and the player max y minus 4 collide with the bomb's position. So this will make sure that the bomb isn't within 4 pixels of the player. So if this bomb is very close to the player, then we don't want to place it there. So let's just go ahead and set the position of the bomb, instead of whatever position we were going to set it to -100 on both axes. We could simply reset it to a new random position, but I think it's more interesting if we set it to a position off of the screen, so that we'll randomly get a number from 0 bombs to 5, rather than simply always having 5. The last thing we need to do is add some checks to determine if the bomb is overlapping the player in the check collisions function. And if it is, then we'll need to end the game. So we'll loop through the bombs from 0 to the count. Once again, we'll get the bomb X and the bomb Y, and we'll need to check if they overlap. So using the object's overlap function, we can once again pass in the player X, player max X, player Y, player max Y, and we'll pass in the bomb X, the bomb X plus 8, bomb Y, and the bomb Y plus 8. And if these do overlap, then we'll run the game over function to end the game. Take a moment to look over all of the code you just wrote. Great job! Now let's try it out for the last time. And as you can see, we have a couple of errors, and the first one right here is because we forgot a semicolon. Even though this is an array and it's spread across a bunch of lines, we still need to add a semicolon at the end of it before we go on to the next line. And all the way down here, you can see we check this player max Y, which doesn't exist in the place bombs function, so we need to check the player Y plus 8. And while we're at it, this should be plus 4 as well, not minus 4. And now it's done. We can walk around with our player, collecting coins and avoiding bombs. Each time the coin is collected, the coin and the bombs are randomly placed. And if we die, it'll show us how well we did. Great job making it all the way through the tutorial. If you'd like to learn how to do more cool stuff with the 8BitCade, check out the links in the description, or check out my channel for lots of tutorials about other Arduino sensors and modules. Thanks for watching.